Welcome to datascience.show, the podcast where data science meets executive leadership. We talk with top AI and analytics thought leaders about turning data into real business impact. If you're a C-level leader or data expert shaping the future, you're in the right place.
I'm your host, Mirko Peters. We explore how data science and AI drive real business impact, straight from the leaders making it happen. Today, synthetic data as an enterprise strategy, a practical playbook for leaders who must move fast without trading accountability for speed. This episode is built for CEOs, CTOs, chief data officers, heads of analytics, and senior data leaders who need decision criteria, ROI levers, and a clear roadmap to pilot and scale synthetic data programs.
Why this matters now. Organizations still struggle with three perennial constraints: privacy, access, and scale. Synthetic data solves those constraints when used deliberately, not as a silver bullet, but as a strategic instrument to reduce risk, increase engineering velocity, and enable model robustness in production. Over the next 25 minutes, I'll walk through when synthetic data makes sense, concrete generation approaches, how to validate utility and risk, integration patterns for production ML, and the governance controls leaders must insist on. Before we dive in, a quick note on the perspective in this episode. I've worked with chief data officers and enterprise teams across regulated industries, finance, healthcare, and telecommunications, where privacy constraints and cross-border rules created bottlenecks for model development. Their approaches inform the practical patterns I'll outline. Think of this as a synthesis of those hard-won lessons, framed for executives making trade-offs between speed, cost, and compliance. Let's start with the question every leader asks. When should you use synthetic data? The short answer, use it when real data is unavailable, high risk to share, or insufficient to train reliable models. Concretely, privacy protection for regulated records, correcting class imbalance and rare event prediction, generating test data for CI/CD and end-to-end testing, and enabling safe cross-border sharing for multi-region collaboration. Those categories map to clear value levers. Privacy-safe synthetic data reduces review time and access gating. Targeted augmentation can turn a brittle model into a robust one by filling important edge cases. Test data generation accelerates engineering cycles and reduces production incidents. And synthetic sharing enables partnerships without exposing sensitive subjects. But, important caveat, synthetic is a tool, not a replacement for high-quality real validation. Always require gated real data testing before deployment. Next-generation approaches and how to pick between them. At a high level, there are three patterns: procedural and rule-based synthesis, model-based generative approaches, and hybrid pipelines that combine rules, constraints, and learned models. Procedural generators work well for deterministic domains, synthetic transaction logs, or simulated sensor data, where business rules define allowable states. Generative models, GANs, variational autoencoders, diffusion models, and LLM-based samplers are powerful for high-dimensional, complex data like text, images, and multi-table records. Hybrid approaches let you enforce business logic and constraints while borrowing statistical realism from learned models. Choosing the right approach is a trade-off. Rule-based systems offer explainability and deterministic control with lower computational cost. Generative models deliver realism, but require investment in training, evaluation, and tuning, and they can hide subtle biases. Hybrid pipelines are often the pragmatic sweet spot for enterprises because they combine governance with realism. Whatever you choose, instrument generation with provenance and versioning from day one. Validation is where many projects fail. Leaders should demand three types of checks: fidelity, utility, and privacy risk. Fidelity metrics measure how well the synthetic distribution matches the real distribution. Think statistical tests, marginal distributions, correlations, and multivariate distance measures. Utility is downstream performance. Does a model trained or augmented with synthetic data perform as well on held-out real test sets? And privacy risk must be quantified. Membership inference risk, re-identification estimates, and, where appropriate, differential privacy parameters. Operationally, require A/B or shadow testing against held-out real data, and define minimum downstream gates before allowing synthetic trained models into production. Track drift. Synthetic generators must be versioned and revalidated when real data distributions shift. Maintain audit-ready validation reports, statistical summaries, downstream test results, and privacy analyses, so compliance and auditors can follow the decision trail.
Integration patterns matter. Don't treat synthetic data as a one-off dataset. Integrate it into your feature store, your ML pipelines, and your CI/CD testing workflows. Use synthetic data for unit tests and synthetic-driven test suites that run in pre-production. Then use shadow deployments to compare model behavior with and without synthetic augmentation. Ensure lineage is end-to-end. Which generator version created which features, and which model version consumed them. That lineage is the backbone of auditability.
Now, to the organizational implications. Who owns synthetic data? My recommendation for most enterprises is a hybrid governance model. A central data science or platform team should own standards, validation frameworks, and marketplace of approved generators. Product teams and ML squads should own tactical generation and experimentation under those standards. Legal, compliance, and privacy need explicit decision rights for release policies. Clear RACI matrices avoid slowdowns and finger-pointing when a synthetic dataset is proposed for production use.
Vendor versus build is the next pragmatic choice. Vendors accelerate early pilots with off-the-shelf models and evaluation tooling. Build makes sense when you need tight integration with internal business rules or when regulatory nuance demands full control. Evaluate vendors on explainability, evaluation tooling, lineage support, and enterprise security posture, not just synthetic realism. Require vendor deliverables that include validation artifacts and APIs for provenance extraction.
Measuring ROI. Pick a small set of business KPIs tied to the pilot. Examples: reduction in data access lead time, % improvement in model recall for rare events after augmentation, number of production incidents reduced by synthetic-driven testing, or time to onboard new partners with synthetic sharing. Translate technical wins into dollar or time savings so the CFO or COO can see value. And always track the counterfactual. What would have happened if teams had used the old process? Looking ahead, over the next 12 to 24 months, expect more standardized validation tooling, tighter integration between synthetic generators and feature stores, and clearer regulatory guidance. Risks will persist: over-reliance on synthetic data that misses real-world edge cases, and regulatory scrutiny when provenance or validation is weak. The practical preparation is straightforward. Run narrow pilots, invest in validation and lineage, and align legal early.
2 actionable moves for executives today. 1. Launch a focused pilot with a clear business KPI. Choose a single high-value use case like test data generation for critical pipelines or augmentation for a rare event classifier. Scope it small, instrument results, and require shadow tests against held-out real data. 2. Establish a minimum governance checklist before any synthetic dataset is accepted for production. Documented provenance and generator versions, statistical and privacy validation reports, RACI for release, and downstream performance gates.
Final reflection. Synthetic data is not a novelty. It's a strategic capability that, when governed and validated, reduces risk and accelerates value creation. Start small, measure rigorously, and build the governance muscle as you scale. From models to measurable value, this approach separates experimental curiosity from enterprise-grade impact. That's the difference between models and value.
If you found this episode valuable, subscribe and share it with your network. And let's connect on LinkedIn. I'm Mirko Peters. We'll be back with more conversations on how data science and AI create real business impact. Until next time.
Thanks for listening to datascience.show. If you found value in this episode, subscribe, share it with your network, and join us next time as we explore how data science drives smarter decisions and better business outcomes.